Good morning, everybody. It is a beautiful late winter's day here on the Martian homestead. Sun is out. It snowed about an inch last night, a little late season snow here. So we're still got about 2 feet of snow on the ground. Today I want to talk to you all about where I'm at with the electronics. It's been a few days since I posted a video on electronics, so sadly, UPS has decided they don't want to come down our driveway because it's too muddy. It's really not that bad at all, but for some reason I think we got a new driver, and he's probably learning how to drive the truck. So I have some feeling there of a little bit of compassion, but unfortunately I was really depending on a delivery from digikey and from Amazon to help get all my electronics done this weekend. And because of his fear of wanting to come down the driveway, sadly, I'm not going to be able to get it done. So what I want to show you today is some of what goes behind the scenes when you want to build some of these circuits and all of the electronics and everything. Now, mind you, so let's see here, right way to say this. I'm not an electrical engineer. I'm not very good at doing electrical engineering, but I think I figured out how to be just dangerous enough to make it work. So you probably have lots of comments on what I'm doing. I'm certain I'm doing things wrong, but at the same time, it's kind of been fun to relearn how to do things. So hopefully for you students out there watching this, this will be something that will be useful for you to actually see, why you should pay attention in class, and maybe it'll also help you with some of the challenges that you have. So let's go ahead and jump in and see what we got going on. Okay, here. I always find that working next to electronics with coffee is a great idea. Not really. Having liquid next to your electronics is not such a great idea, but it's early in the morning. I haven't got a lot of sleep lately, so coffee it is. Last time I talked to you all, I showed you this mess. And all of this was getting routed into Arduino, right here. And lots of great comments that reminded me of things that I was told in class many, many years ago. So what we want to do, instead of having this big pile of wire here that then gets routed into the Arduino individually, we want to have something that looks a lot cleaner like this. We want to go from that to something that looks like this. This isn't the end product. Again, go from this to this. How are we going to do that? Well, I already have some of these dev boards here. So if we look at these, kind of get you a close-up. One side is clean, and the other side has all the solder points on it. So what you do is you take something that has pins on it, and you're going to put those through there, like that. And then you would solder each of those points in order to start creating circuits. So you're taking your breadboard that you've done. Let's see here. Breadboard. There's a breadboard. Kind of loosey-goosey. How you put everything together, and now we want to make it more permanent. This is still not a truly custom printed circuit board, but for where I'm at in kind of re-triggering the old brain cells, getting them going again, this is a nice place to start, I think. Certainly, you could create a circuit board and send it off to get printed, or I actually watched quite a few YouTube videos. YouTube is actually pretty darn good at learning things. Who would have thunk? Anyway, you can actually get kits where they send the copper and the board to you, like a single layer board, like this one, and you can etch on it or print on it with a laser printer, and then actually use acid, and you burn away the copper that you don't need, and it leaves behind a really pretty circuit board, something much closer to this than what this is. So what I'm deciding to do is we're going to actually, I need to take what was on my breadboard, to take this whole pile of wires, and I need to really figure out how I want to route everything on this board. So what we're going to end up doing is we're going to have, I'm replacing the RJ11 jacks that I used here with RJ45. Now, the reason I'm doing that, these are the actual RJ11 little itty-bitty jacks here, your telephone jack, and at first I thought these would be fine, and I thought they would be inexpensive to buy. And the little connectors that go into the faceplates here, so it all looks good, I thought they'd be fairly easy to find and buy as well. Sadly, actually not sadly, everybody's going to RJ45, so let's see here, we want to go from these small little connectors up to an RJ45 connector. So you can see there the differences. Hopefully the autofocus kicks in. So the reason we're going to RJ45 isn't because we need more signals. RJ45 is bigger, it can hold more wires. It's because of cost, really. It's just the components are a lot easier to find in RJ45 format than they are the RJ11. So guessing half of you are probably phasing out right now as I talk about these connectors. But let me tell you, if you're not familiar with this stuff, connectors are like one of the most important things that I've come to appreciate. It is a pain to figure out how to make all these connections. And there are so many choices out there that you kind of just got to go with what works for you. So anyway, we're going to replace this stuff with RJ45. And then instead of having these particular type of clamp connectors where you have all this wire on the back, these you just, there we go. You just put your wires in there and then you clamp them down. We're going to go with a pass-through. And what I mean by that is we'll have, get my little prop back here. We'll have an RJ45 that connects on this side, nice and clean. And then on the back side, we're going to have an RJ45 as well. So that instead of this big mess of cables, I can actually create really nice looking cables using the RJ45 traditional cable that you would see. So it'll be a lot nicer, a lot cleaner. And I don't have a prop for it because UPS didn't get my delivery. So I'm going to have RJ45 on one side of the cable, and on the other side of the cable, I'm going to have, I think they're JST connectors, which are a lot smaller. And those connectors are going to mount onto this board. So we're going to have 8 connectors total. So it'll be 1, 2, 3, 4, 5, 6, 7, 8. We're going to have 8 connectors. And those are all going to mount on here so that each of the cables will plug right in to the board here very nicely. And then essentially we're going to take wires like this and we're going to bring them to the edge of the board here. We're going to snip the ends and we're going to just go hard right onto the board. That'll be good enough for what we're doing right now. It's a prototype. There'll probably be plenty of things that I want to do differently, but I want to get this up and running. This has been months in the work, as you know, trying to get these sensor suites built. I had hoped it would be a lot easier than what it is, but it's not. So I think I kind of gave you the general, here we go. In order to get all the signals that I need, here's one of the mistakes I made. When you're looking at the Arduino, here, okay, hopefully you can see this. Right here, there's a little signal called A0, and that signal is analog. And all these sensors that I have, with the exception of 2 of them, are analog. And I had thought, when I looked at A0, there's 2 or 3 pins, or 4 pins, I think. 1, 2, 3, 4. 4 pins below it for a total of 5. And I thought all of them were analog signals. And when you look at the board, it kind of, because I have them all pinned in here. So I thought that there was enough analog signals to handle everything I needed. But there wasn't. There is actually only one analog signal. So what you need in order to deal with that is this little guy. This is a Breakout Board, meaning that they took the thing I needed, which is that little device right there, which is called a multiplexer, and they actually put it on a board so I can put the pins in and actually use it. So how does that work? Let's take this apart. So the way that I set this one up is I custom soldered everything on there, and then you essentially just do this right there. And this is how I put it all together. And I had it all working. I had the sensors working with the exception of the power problem that I've talked about in my previous video, which we're going to solve with this new approach. So anyway, we got to take that little component right there, and we got to shove it on a board like this. So those parts are on the way. The connectors are on the way. Everything should have been here right now, but unfortunately, again, wasn't able to get that rocket ship delivery. Which kind of, if you think about the Mars stuff, these are the types of problems that they might face. When you run out of stuff and you need new things, there's really no place that you can go. So I would definitely like to have a whole slew of electrical components with me when I went somewhere like Mars or the moon, and a 3D printer and a PCB printer. Both of those are things I would want to have. Anyway, hey, so I'm going to stop talking, and we're actually going to look at some computer stuff here, some schematics and what have you, because what we need to do, what I want to do, one is I want to relearn how to lay out, how to do schematic work, because I forgot, and I also want to kind of get a good picture of how I want everything laid out on this board, where I want to put everything, and how am I going to connect it all, and how I'm going to route everything. So I'm choosing to use Eagle as my schematic and layout tool. So let's jump into Eagle and see what we got going on there. Okay, here we are in Eagle. And Eagle is electronic computer aided design software, ECAD. And the purpose is to help build electrical schematics, like what you're looking at here, and then convert them into layouts that could actually be fabricated on a printed circuit board. At least that's how I'm going to be using it. So this is my very rudimentary schematic. Again, remember, I'm not an electrical engineer, so be gentle. I'm learning how to do all this. It's taken me about 3 days to learn how to get here. I had no idea how to use this software when I started. So I just sat down and started watching some YouTube videos, great videos out there. I highly recommend people to go check them out on how to use Eagle and how to get started with your first schematic, how to choose your components. So the first thing you have to do is actually go to a library here, and you actually start typing in all your things that you want, like resistor or connector, and then you can choose different connectors, and it shows you everything here, and it puts them on the schematic for you. So you got to get all those components and throw them down first. So let's talk about my components here, what we have. The very first thing is this power in connector. This is 12 volt power coming in, and then off of it we actually have another connector going off of the board that's going to be power out to the actual Arduino itself. Then we have a 5 volt regulator, which is taking 12 volts and bringing it down to 5 volts. And originally I was going to do a voltage divider here, and then I got a ton of feedback. It's like, that's a horrible idea. Why would you do that? They actually make a component that does exactly what you want. And I'm like, really? I didn't know that. So hey, to all you students out there, make sure before you get all crazy about designing something, go with the theory that there's nothing new. If you've thought of it, someone else has probably already thought of it and done it better. That's just the way it is. There's tons of components out there as I'm learning. So make sure you ask first before you go and get crazy about designing something. So I got a 5 volt regulator that goes from 12 volts down to 5, and that's what everything on this particular board is going to need is 5 volts. So kind of moving around here, we got our ammonia connector, fish tank temperature sensor, photosynthetic absorbable radiation sensor, say that 3 times fast, temperature and humidity sensor, and then this particular sensor right here, the fish tank sensor as well as the grow bed sensor down here, are called one-wire devices. So that's a particular protocol of communication, and they require a resistor in between the positive and the signal. So we've got that put on there. Now you follow all the way around. Here's the multiplexer taking all those signals and making them one, and then I need to make sure that my one-wire device is actually going to the digital output, because that's a digital signal, not analog. So it looks like I messed that up. That's why we do this. And then over here is an actual voltage divider. This is for the signals coming off the multiplexer. The sensors that I'm using are 5 volt sensors, meaning that their output is 0 to 5 volts. And the Arduino can go all the way up to 3.2 volts. So 5 is greater than 3.2, so we don't want to get a bad reading. So we're going to step that voltage down. And it was recommended that I use a potentiometer here, but I just didn't even know how to choose the right one. So I'm just going to go with some resistors that I have on hand and create a little voltage divider, which I've done on the breadboard, and it worked. So we're going to go with that for right now. But in the future, I think these 2 resistors will get replaced. And then we have all the other connectors here for the dissolved oxygen, pH, the bed temperature, and the nitrite sensor. And I just realized that the whole reason I was doing all this and putting this thing in is for a carbon monoxide sensor, and it ain't on here, so I better get that fixed. That's why we do this. So you hit a button in Eagle and it will create a layout view, and that's what this is. You tell it how big your board is, which I did. That's the white line here, and then it grabs from that library that I showed you. It grabs those components that you have, and it actually puts them down in their actual scaled size. And then your job is to connect everything. That's all these lines that are on here. So for example, kind of highlight this, see how that's bright red. That's the 5-volt bus. That's all 5-volt power being provided. I could do this. There's the 12-volt bus. I can click on this. There's the 1-wire bus. I can click on this. There's the ground bus. Here's all the signals coming off the multiplexer. Here's my resistor for the 1-wire. Here's the voltage divider. Here's the connector going out off the board for power. Here's power coming in. And here are the signals that we're going to be soldering the wires to that I showed you earlier. So it's not too hard to learn how to do all this. So at first I was overwhelmed, but you just start working the problems. You just get into it, watch some YouTube videos, play around, and eventually you get to something that actually, I think this looks halfway decent. What I learned on this is that there's pretty much no way that I can route this board using a single layer. Everything overlaps, as you're seeing here. All these lines overlap. So we're going to be using wires to create multiple layers. And I think for what we're doing right now, that's going to be fine. But in the future, I would actually like to turn this into a custom board, and you can actually send it out right here. It looks like I hit this button and I'll send this board to someone who could actually fabricate it for me and send me my specific custom board, which would be pretty cool to do one of these days. But for right now, I just need to get this thing going. So there we go. That's what we did in Eagle.
So there you go. A little bit of me relearning how to do things. I'm certain I probably didn't do it very well, but that's part of the learning process. As you know, is you just start. And I remember in the Martian, obviously an inspirational movie for me, at the very end, he's talking about, what do you do? How do you survive? And Watney, the character, Matt Damon's character, says, you identify one problem and you work the problem. And then you go on to the next problem and the next problem and the next problem. Eventually you solve all the problems and you come home. At least that's what you hope for. And this experience has been very much like that. Things that I know, things that I remember, things that I've been taught, but I haven't used, that information is in here. That's the problem. How do I get that information so I can actually start using it again? So I start doing stuff. Okay, well, how am I going to do all this? Oh, well, breadboard. All right, I remember that, so let's put it all together. And then you get to this and you're like, well, this is total garbage. I don't want it to look like this. So then we start thinking about these types of things. And then eventually I'll start getting to the point where I just create a circuit and send it off. Create a board and send it off and have a custom one made where it comes back and it looks, professional like this. And maybe put a little symbol on there and maybe sell those to people would be a very nice thing to do. But it's just solving one problem after the next, Okay, so I need to get stuff on here. So how am I going to lay that all out? Well, I don't really want to draw it because I want to use it consistently and I want to see where my problems are at. And I want to update the design. And I want to be able to share it with people. So let's go digital. Okay, next problem. What digital software am I going to use to create the digital image? Okay, well, there's Eagle, there's Bolt Swing or something like that. There's a few of them out there. Well, I'm going to go with Eagle. Well, how do I use it? And you sit there and it's just one problem after the next. And, I figured out how to use it. And, okay, so I do a schematic. I forgot how to do a schematic. What parts do I need? How do I look up those parts? All those things have been things that I just have to keep dealing with. And sometimes that gets really frustrating. I won't lie. It's kind of disheartening to know that I used to know how to do these things and I've forgotten. But I'm working my way through it again. And we're getting to the point now, as you see, I learned how to do layout. I haven't really done that forever. I've never done it, really. College, we did some stuff, but not a lot. So here we are. We're going to see if it works once those darn components show up from UPS. So UPS, if you're listening, please make the delivery. The Martian needs the rocket ship to make the delivery. Otherwise, I can't build my stuff. So anyway, it's been fun, but it's been a challenge to get to this point. So next videos, hopefully I'll be able to show you actually this board getting populated and actually having something for you guys to look at. So That's it for this video. If you've enjoyed it, hey, be sure to give it a thumbs up and hit the subscribe button. And if you want to get notified of our new videos, hit that little bell to the left to subscribe. In the meantime, this is The Real Martian. Out.